Hello everyone. So today is going to be a basic concept from organic. So we are actually going to see the flow chart of how any organic reaction will happen, right? So now I'm going to bring you some terms and I'm going to explain it. So we'll just directly go into it. So in any organic reaction for that matter, right, or in any case, or in even case of any chemical reaction, I'm going to have certain kinds of reactants and I'm going to have some products. Right. So this flow chart which you're going to see now is going to explain what exactly is happening inside an organic reactions, right. So now this reactants term I'm not going to use anymore in terms of organic chemistry. The term which I'm going to use is what is called as substrates. So substrates are the one which are going to involve in the chemical reaction, involve in the organic reaction, right. Okay. Now these substrates are going to get attacked by something called as reagents, right. So these reagents and substrates are going to react together, and there's going to be some middle stage where I have something called as intermediates getting formed, right. And again these intermediates are unstable, so they will not be able to stay there for a longer time. So what will happen is they will lose something or gain something to form the final products. So I think the flow chart looks very simple. I'm going to have something called as substrates, and these substrates are going to get attacked by something called as reagents. These two will react together, and at some point of the chemical reaction, I'm going to form certain unstable species called as intermediates. And since these are unstable, they'll gain something or lose something to form the final product, right. Now the entire organic chemistry is a study about all of this, right. I am going to study about reagents, I am going to study about different kinds of substrates, different kinds of intermediates, and obviously the product also associated along with them, right. Say for example, if I look at what can be reagents, right, like generally speaking, the reagents can be of two types, right. Say now they can be called something called as nucleophiles, or they can be electrophiles, right. So nucleophiles, as the name tells you, nucleus, phile, loving, so these are positive charged loving species. And electrophiles, electron, philes means loving, so these are negatively charged loving species, so they have high affinity for negative charge. The nucleophiles have high affinity for positive charge. So now generally, okay, now I can further classify them, right. So but I don't want to speak about it today. I want to lay my interest upon what are these intermediates, right. So for me to understand that, so for me to understand what exactly are intermediates, I have to understand how a bond is broken in organic chemistry. So when I talk about bond cleavage or bond breaking, right, in organic chemistry we will be able to tell them that it can happen in two ways. Something called a homolytic bond fission or bond cleavage, and I have something called as heterolytic bond fission or bond cleavage, right. Now I'll be able to easily explain them. So this is how it goes. Say assume that I have a CC bond, right, and obviously other three bonds are also there for each carbon atom, right. Now you obviously understood that for me to form a single covalent bond, one electron has to come from carbon and another electron has to come from this carbon, isn't it, right. Now I am going to break the bond in such a way that, like something like this, I am going to break the bond something like this, so that wherever the electron came from, that means the electron came from here, the electron goes back to this carbon atom, and this electron came from this carbon atom and it is going to go back to this carbon atom. It is very simple, right. So now at the end what is going to happen? If this happens, what am I going to get? I am going to get something like this, and again something like this. So this extra dot represents the odd electron which is present, right? So now I'm going to give you some special terms to this, right? I am going to call these kind of odd electron species as free radicals. Now please understand, whenever homolytic cleavage happens, I will always end up only in free radicals. Now this is the first type of intermediate you are going to know, right? Now going there, if I go for heterolytic cleavage, now say I take a CCl bond, obviously I have this, right? So now again I have two electrons shared, one coming from each carbon, another coming from chlorine. Now I am going to break the bond in such a way that two electrons goes to one of the atoms, right? Now please understand that chlorine is way more electronegative than carbon, right? So I am going to break a bond such a way that this entire two electrons are going to go to chlorine, right? So now you can guess what I am going to get the result out of it. So definitely chlorine has already one electron, now one more electron is coming from this also, so it is going to become Cl minus, right? And what happened to this carbon? Now this carbon had, like, it has 3 bonds already and it has lost one electron, so definitely this carbon is going to have a positive charge, right? Now this is again going to be an intermediate called as carbocations. So you can understand carbon having a positive charge, carbocations. Okay, one last step. Now you saw in this case that carbon is losing the electron. Now what can be the other case? Carbon is going to accept the electron, say something like this: I have some X which is less electronegative than carbon. So again I am going to have 2 electrons and I am going to make these 2 electrons come back to carbon. So what we will understand that this carbon is going to have a negative charge now because the extra electron is getting added, and whatever was remaining has lost the electron, so I am going to have a positive charge here, right? Now this whatever I have here, that is carbon possessing a negative charge, are what are called as carbanions, right? So these 3 are going to be the fundamental intermediates in my organic chemistry. These are free radicals, carbocations and carbanions, right? So free radicals are neutral species, they just have one extra electron, that's it. But carbocations and carbanions are going to be charged species, and carbocation is positively charged, carbon is negatively charged. So we will give more insight to all this, determining the stabilities of different types of carbocation, in which reaction which intermediate comes, how are we going to predict it, all that we will see in the further classes. Thank you so much.